In this video, I'm going to talk about the programming language that's built into Lantern. It's a subset of C, so if you programmed in any of the C-like languages, C, C#, C++, PHP, Java, JavaScript, you're in good shape. None of this will be a surprise. So let's talk about variables first. Variables are just a chunk of the computer's memory that we can slap a name on or refer to using a name that we can use to store a value that we need to keep track of. There's only one type of variable in Lantern, and that's just a byte. There's no like int or string or float or bool. There's bytes, and you can use them as kind of integers, or you can use them as bools. And that's kind of it. It's pretty simple. The rules for variable names are the same as other languages. You can't have a space in a variable name, and they can't start with a number. And variables can only hold values between 0 and 255 because they're only one byte in length. So if you're going to have a scoring system, I would make your score go from 0 to 100. If you're going to have a health system, have health go from 0 to 100. And if you go below 0, what will happen is the number will wrap and it will become a high positive number, and you can code for that, or you can check that. So just be aware that there's no negative numbers. Variables can only hold values between 0 and 255. So what do you store in a variable? You could store anything. A Boolean, a 0 or a 1, indicating whether something has happened yet or not happened yet, maybe for the purposes of making things happen in your game or for tracking a score. If you have countdown timers, you've lit a fuse on a cannon and it's burning down. Well, you could have a countdown timer. You could have a count up timer. You could count moves, and when you pull the lever, there's 3 turns until the drawbridge drops or something. You can use a variable for a count up or count down timer. You can track resources or consume resources. So, health, if maybe the player's been poisoned and they have 10 turns to find the antidote or something, right? So every turn you subtract 1 from the player's health. Or there's a battery, that's running down in a flashlight, or a torch that's burning out or something like that, or the player's lost in the desert and their thirst is increasing, right? So you can use variables for stuff like that, and you can use them to store the health of an NPC, not necessarily the player, or the state of an NPC. So it's like, is the guard asleep? Is the guard patrolling? Is the guard dead? Right? Those 3 things. Those would all be states that maybe a guard could be in or an NPC could be in, right? And you need to put that in a variable. So a variable can just store pretty much anything you want, as long as it's just a number between 0 and 255. But what that value actually represents can be determined by you. There are several built-in variables already, stuff that just gets used all the time in every game. So score, moves, health, and then there's turns without light, because the very first game I wrote using Lantern, I just built this thing in because it was a Zork-like thing where if you're in the dark for too long, or adventure-like thing, if you're in the dark for too long, the cave collapses on you. So the game tracks how long you've been in darkness. But you can certainly add as many variables as you need. There's a tab in Lantern's interface for adding new variables. So how do you set the value of a variable? Well, you can set it to its initial value inside of Lantern, but in the code, when you can change the value using the equal sign. So in this example here, I'm assigning the value of 100 to health. So the single equal sign means take the thing on the right and put it in the thing on the left. And notice that this statement ends with a semicolon. In the Lantern language, just like C, everything's going to end in a semicolon. So what we're doing here is assigning health to be 100. We are taking the thing on the right and putting it in the thing on the left. That is what one equal sign means. So we're taking the number 100 and we're storing it in health. So that's how you can change the value of a variable or set a variable. So what if the thing's already been set and you want to change it, like want to add 1 to a variable, or subtract 1 from a variable, or add 5 to a variable? You could write something like this: health equals health minus 1. So this would subtract 1 from health. So remember the single equal sign means take the thing on the right and assign it to the thing on the left. So the right side of this statement says, okay, get the value of health, subtract 1 from it, and then where do I store that? Oh, in health, right? So it's load the value of health, subtract 1 from it, and then store the result back in health. So that would be how you could change a variable, by subtracting 1 from it. Here's another example. Let's say we want to add 10 to our score. You could say score equals score plus 10 semicolon. So this means take the thing on the right, stick it in the thing on the left. Load the value of score, add 10 to it. Now we've got score plus 10, and then we're going to store that result back in score. So we're going to load the score, add 10 to it, and then take that temporary or that new value and store it back in the score. So that is how you can change a variable. And then Lantern does support the usual shortcuts of minus equals and plus equals. So health minus equals 1 is a shorthand for health equals health minus 1. That means subtract 1 from health. And the example here, score plus equals 10, that's a shorthand for score equals score plus 10. So if you are an experienced coder and you know these tricks, these little shorthand things, yes, use them. Lantern supports that. So that would add, this would subtract 1 from the health, and this one would add 10 to the score. Okay, so what else are we going to find in Lantern's programming language besides variables? The comment indicator is the same as in C, I guess the C++ programming language. So double slash means that is a comment. So anytime you are writing code, the double slash indicates the start of a comment, which is just a note left by you in the code, and everything after that is ignored. So I usually put comments in my code, so I remember what I was doing. And then semicolons. Every statement ends with a semicolon. So let's take a look at this example here. Print line hi, semicolon, slash slash. This is just a note, right? So what this is doing is it's printing out the word hi, and then the semicolon ends the statement, and then we hit the double slash, and that says, oh wait, hang on, there's a note at the end of this statement that's just there so the programmer remembers what this code was doing, right? So that's what this is doing. We've got the double slash indicates the end of the code and the start of just a note that you put in there so you remember what that code does. All right, let's look at some other things that we use all the time. Printing text. How do you print text to the screen? There's a couple of functions. There's a print function, and if you want to print a word to the screen, you just put the text inside of the double quotation marks and semicolon. So this would print the word hi on the to the screen. However, what this will do is it'll print the word hi, but then it won't print out a carriage return. And if you actually wanted to print out a word or a sentence followed by a new line, that's print ln or print line. And then what this would do is print out the word hi followed by a carriage return or an enter. And again, notice we've got the text in quotation marks. There's no string concatenation. You can't say print line hi plus the name of some object plus some integer plus another string. You'd have to just do that using separate print lines or print statements and print line statements. It turns out that that works fine. Okay, so what else have we got? We've got print and print line. How do you generate random numbers? A lot of times you need that for combat or maybe picking a room to put something in. So there's a function called rand, which is built into the language, and you give it the value for the upper limit. So this would generate you a number between 0 and 24 inclusive. So it doesn't include the upper range. Rand 25 would give you a random number between 0 and 24. And this statement says, okay, generate a random number between 0 and 24 inclusive and take that and assign that to damage. So there's a rand function. All right, what if you want to compare things? It's just like C, C++, Java. Double equals means test for equality. So there's a big difference between one equal sign and two equal signs. One equal sign is the assignment operator, which we already looked at. The double equal sign means compare or test for equality. So let's look at an example here. Health double equals 100. This is a comparison. This is a question. Does health equal 100? So there's a big difference between one equal sign and two equal signs. Now you're never going to see just like a line of code like that. It's going to be, if you're testing an expression, it is going to be within the context of an if statement or a while loop. So let's go look at what that would look like. Now, can you test for inequality? Can you test it? What if you wanted to test if health wasn't equal to 100? Could you do that? Yes, that is the not equals operator. And then this is just like other programming languages. So exclamation point equals, that means test for inequality. Now, when you're testing an expression, it's going to go inside of parentheses like this, usually following the word if or following the word while. And the code to execute, if this whatever you put inside here is true, is going to go inside of curly braces that follow it. So let's look at an example here. So here's an if statement. It's like one of the fundamental building blocks of programming. What we're going to do here is we're going to have an if statement, and we're going to test, is health equal to 100? The double equals is a question. If health is equal to 100, do the stuff between the curly braces. So if health is 100, we're going to do the stuff between the curly braces, which is going to print out the line, you feel perfectly healthy, period, and then drop down to the next line. Oh, great, the dog just started snoring. Awesome. So an if statement is tests an expression. If that expression is true, then the following code in the curly braces will get executed. So if health were not equal to 100, we wouldn't do the code inside of the curly braces. All right, and notice that there's no semicolon following the if statement. I see a lot of people, they think, oh, okay, I need semicolons at the end of every line. Well, not if you're testing an expression, not after an if or a while, because what would happen is if you put a semicolon here, the semicolon means the end of a statement. So you're saying if the health is equal to 100, do whatever comes after the expression. And if there's a semicolon there, that gets treated like an empty group of statements. So that would end up being, if health is equal to 100, do nothing, and then always do the stuff in the curly braces. So the moral of the story is don't put a semicolon after an if statement or a while statement. We'll talk about while loops later in a different video. Now, to help you write code that it is sort of easy to read, I would let Lantern write as much of the code for you as possible. So if you type the word if and hit the tab key twice, Lantern will stub out an if statement for you. If you type out the word else and hit tab twice, Lantern will stub out an else statement for you. And I know I haven't talked about else statements yet, but the idea is Lantern's got these little shortcuts built in that will make sure that you have the correct syntax, right? You've got your parentheses with the curly braces following it. One of the things that people do all the time is they get their curly braces out of whack. They forget one, and then they get an error and they don't know what to do. But if you let Lantern write code for you, then you won't have those problems. All right, so what if you need to test more than one variable at the same time, or more than one property of an object or something? You want to test if this is true and that's true, or this is true or that's true. Then do something. Well, how do you represent and or? And that is exactly the same as in C and C++. The double ampersand means and the double pipe key, which is above the enter, means or. Let's look at an example of that. So what this is saying is if health is greater than 25 and health is less than 75, then do the stuff in the curly braces, which says print out the line, you feel okay, not great. So you're like, yeah, whatever, you're all right. So that's called a compound operator. So for the statement to be executed, the body of the curly braces to get run, both of these conditions have to be true. Health has to be greater than 25 and health has to be less than 75. Both of those have to be true. Right, which is what I just said. And then let's look at an example with an OR, which is the double pipe. So with this, I would read this as, if health is equal to 0 or time is equal to 0, print game over, right? Because we ran out of health or we ran out of time. So there's an example of a compound operator, or a compound expression. All right, so we've looked at variables and how to test them. Now let's look at objects. So objects have two types of values, or they're a wrapper or a group of two types of data. So there are attributes, and those can have a value of 0 to 255. And then objects also have properties, which can just be a 0 or a 1. So there's no difference internally between a room and an object. They're all things. I mean, imagine a barrel, like it's an object, but it's also a room, like you could get in the barrel. So internally, your game is really just a big table of objects, and objects have attributes which can be 0 to 255, or they have properties which can have a value of 0 or 1. So let's look at the values and that an object can store in its attributes and its properties. So every object has the following attributes shown here on the left. It has an attribute called its holder. That can also be referred to as its parent or its location. Those are all synonyms. That is where that object is. It's who owns that object, where that object is in the world. It has a description. It has an initial description. So what's the difference? I'll explain that in a second. It has the locations of what object you'd go to if you went in a particular direction. So imagine you're in a room. That room's north attribute stores the number of the room that you go to if you went north from the current room. And then we've got in and out. Those are directions as well. Objects have a mass attribute, and that's how much they weigh. And there's an amount that the player can carry. And if you want to have puzzles, like, you can't carry the two large things at the same time, you can assign a mass to the two big objects, and that way the player wouldn't be able to carry both of them. I think the player has a maximum inventory of 25, like 25 pounds or something like that the player can carry. And then those are the attributes. So the attributes can store numbers between 0 and 255, and then an attribute or an object also has properties. Properties have a value of 0 or 1. Let's look at those. So portable, that can you pick it up or not? Is the thing a container? It means, like, can you put things in it? Is it a supporter? That means, can you put things on it? Is it open? Is it a door that leads to another room? Is it lit or emitting light? So if you can see in a room, then its lit property would be on. Is it something you can wear? Is it something that you're currently wearing? Is it something that can be opened? Is it something that can be locked? Or is it locked? Is it something that can be locked? And scenery is stuff that I talk about in the text adventure writing video. That is scenery is sort of stuff that's in a room, but it's invisible. And if you happen to look at it, you'll see a description of it. Like it's usually a scenery object means it's, when you were describing a room, you mentioned something like you're in a cave with stalactites hanging from the ceiling. All right, so you'd want to put a scenery object in there for the stalactites in case the player types examine stalactites. You'd want to have a response. So scenery objects are kind of invisible objects that are in a location in case the player tries just to look at them. And then there's 4 properties that you can use for your own stuff. So there's user 1, user 2, user 3, user 4, and those can be used for, like, defining regions of your game, or is this an above ground region, or is it a below ground region, or if you can use, maybe you've got something in your game and it can be hot or cold. You could use one of the user flags for that, or the little user bits for that. Now, to get or access to read or write a property on or an attribute of an object, you use the dot operator, the period operator. This is just like, you know, many other programming languages. So it takes the form object dot property. You know, let's do that. Object dot property. Whee. So let's take a look at that, how that works. So let's say we want to change the player's holder to be a room called cave. What we're saying here is take the number cave, or take the cave and put it into the player's holder, right? The thing, read it, the dot as the apostrophe S. This torch dot lit equals 0. That means set the torch's lit property to 0, meaning turn off the torch. Maybe there's a steel door in our game. Steel door dot locked equals 0. That means unlock the steel door. Take the number 0, store it in the steel door's locked property. Right. So think of 0 being false, 1 being true, or 0 being no and 1 being yes. So is the torch lit? No. Is the steel door locked? No. So that's how you access the properties and attributes of an object. You just have the object's name, dot, and then the property or attribute that you want to change. So let's look at this example here. Imagine this is the function that gets called when you try to examine a torch. You could say if torch dot lit equals 1, that means test to see if the torch's lit property is 1, and if it is, print the line, the torch is burning nicely. Otherwise, print the torch is out, right? So we're using the dot operator in conjunction with the torch to go in and get out a particular property. So if you just read it as the apostrophe S, you'll be in great shape. If the torch's lit property is equal to 1, then do this. Otherwise, do that, right? Print the torches out. And we just kind of went over that. So that's it for this slide deck. There are many functions that are built into Lantern, and if you actually just look at the Lantern interface, you'll see them. They're all printed right on the in the Lantern interface itself, and you can see what they are. The language is very similar to C. So we have print and print line for writing text to the screen. We have a function rand for generating random numbers. The single equal sign means assign a value to something else. It's an assignment. Take the thing on the right, stuff it in the thing on the left. Double equals means test for equality. Exclamation point equals means test for inequality or not equal to. Read the exclamation point as not. Double ampersand means and. Double pipe means or. And then if you're going to test an expression, that expression goes in parentheses. If the expression is true, it will execute any sort of following code in the curly braces. But again, just type if tab tab, else tab tab. Let Lantern write the code for you, and you will be spared the agony of missing parentheses and missing curly braces. So that's it. And it turns out that just by changing those properties and attributes on objects, changing the holder to move objects around, or changing the north, south, east, west attributes of an object that would change how those rooms are connected. And then all of these properties here on the right, if something is something portable, is it a container, is it open, closed, locked? By just manipulating all of these things, you can create a remarkably rich and immersive world. And that's kind of why I like this stuff. There's an amazing there's an amazing simplicity under it that somehow allows you to have these really kind of fun little clockwork universes. So that's it. And then in many other videos, I will show you like how to do specific scenarios. Locking doors, unlocking doors, monster drops, digging for treasure, all that stuff. Bridges that collapse underneath you. How to walk past the guard without waking him up. How to wear the disguise. How to put on the gloves so you can pick up the poisonous mushroom. All that stuff. So it turns out just with if statements and these attributes and properties, you can create all of that. All right, so I hope you found that intro to Lantern's programming language useful. And then, if you have any questions, email me. And or I would say go to textadventure.net or the T Drive folder where I have all the tutorials, and find the specific videos that are most helpful to you. So thank you for toughing it out through all 25 minutes.